Howdy, howdy, this is Mr. Potter. In our previous unit, we talked about the stack. It was one of the data structures we had in which the data is entered into it, and then once another piece of data is added onto it, this previous piece of data is inaccessible until we get out this data. In other words, the last thing that we put on is going to be the first thing that we can access, and we call this a first in, last out, or FILO type of access. The thing is, when I'm looking at my stack, I'm only going to be able to see the top. So this is the only thing that I can peek or pop from. And I have to pop this off in order to get access to the element that's below it in the stack. We're going to be talking about a queue. And if you've ever had to wait in line for anything, let's say that we're waiting in line for the magic pink box over here, a queue is essentially a line. So the first person that arrives and the first person that gets into line is going to be the first person to be able to access the queue. Any other people that follow afterwards are going to have to wait for this person to get out of line before they can access the cube. And so what happens is the first person that was entered into the system is going to be the first person out of the system, because this person's going to access the cube and then they're going to leave, which allows the next person to be able to access. And any subsequent people that enter this queue is going to have to wait their turn to get to this cube. So that's the idea behind a cube. The question is, how are we going to implement this? Well, we're talking about arrays here. So we've been dealing with an array structure. Elements in here are going to be in the arrays. So I've got 0, 1, 2, 3, 4, and so forth. And we're going to have to keep track of the head of our queue and also the tail of our queue. So these are going to be two integer variables that are going to keep track of where the first position is in our queue, the first position that's going to be able to be removed, and the last position in our queue where new data is going to be entered. Now, when we're talking about entering something into a queue, we call it enqueuing. And so if I want to enqueue stuff, I'm actually going to enqueue at the tail, which means tail is going to move one position over as this spot gets filled. And then if I want to remove stuff from a queue, that's dequeuing. Dequeuing. And when I dequeue, I'm going to be changing the value of head. So head will move over as this position is removed. And of course, we're still going to implement the idea of a peek, a non-destructive way to access the element in a queue. So we're always going to be able to access the first part of a queue, and the last part of the queue is where we're going to be able to put information in. Now, again, because I'm dealing with enqueuing, which is going to add more people and add more people and add more people, eventually I'm going to run into the situation where I'm going to want to add into a spot that's empty. So we're going to need the notion of resizing, just like we did with our stack. And then of course we're going to need some way to determine if we need to resize. Notice that if I need to resize, I'm going to need to check to see if my tail is accessing a position that's not in the array anymore. And when I resize, I'm going to resize, but also keep in mind that as I've been dequeuing, my head may be at some position here. In other words, my data may be in this position. So when I copy that over to a new array, I'm going to want to copy it over so that this becomes my new position 0. This becomes my new position 1. This becomes my new position 2, and so forth. So our resizing is actually going to resize but also reindex. But I have to reindex in such a way that I don't lose this data. So this is what we're going to implement. And by the way, we still have to keep track of the idea that if I'm trying to dequeue from an empty queue, that's a bad thing. So we're going to be throwing an exception just like we did with our stack. So let's take a look at our code. So what I'm going to do is I'm going to create a new file. We're going to go ahead and call this queue.h. And we're going to put in the stuff that we're going to work with. So just as we did before, we're going to do a define. And the reason we're doing that is so we can either include the ArrayQueue.h or the ArrayQueue.cpp. I really need to call this ArrayQueue. Let me save this as a different name. Because this is an ArrayQueue, it's not just a queue. So I need to change this. This is ArrayQueue. All right, so again, I want to make this queue flexible, which means I can make it a queue of anything, and we're going to do that with our templating. Class T, and this is going to be our class Q. So, I have the stuff that's public, and I have the stuff that's private. In our public, of course, we're going to need the constructor for our queue. So I'm going to start off with something. I'm going to go ahead and say the size is 5, just like we did with the stack. Our data is going to be a new array of t elements of size, whatever our size variable happens to be. And our head is going to be set at 0, and our tail is going to be set at 0. So in other words, the first position that I'm going to be able to insert is going to be my head, and the first person I'm going to is my tail, 0, and the last place that I'm going to be able to pull from is my head, which is also 0. Now I'm also going to have my public method, so I'm going to have void enqueue, which is going to have a t data. I'm going to have t dequeue. Remember, this is our destructive dequeue, and then we have t peak, which is our non-destructive way to access it. And then, of course, because we're going to throw an exception if we try and dequeue from empty queue, we need a way for the user to determine if it is empty. So that's going to be our public information. For our private information, of course, we're going to need an array, which we're going to call data. We're going to have an int head, tail, and size. These are all integer variables that are going to keep track of the first position to remove from, the first position to insert into, and the size of our array respectively. And then we're going to need our helper functions, the Boolean need to resize and our void resize. So, and then that's the end of our class statement. So then we're going to include ArrayQueue. So once I've done that, now we're going to create another file, which is going to be called ArrayQueue.cpp. And this is going to contain the code for our array. So what we need to implement here is, of course, check first if it's not defined the q_h. In other words, if we haven't implemented, if we haven't included ArrayQueue.h, then we want to include it. And now we're ready to start writing our methods. So we have our two helper methods, our need to resize and our resize. So we're going to go ahead and template class T, and we're going to have our bool q of class T, and this is going to be need to resize. And we talked about how if I needed to resize something, let's go back to our data. If I need to resize something, I'll know if I need to resize if this position here, this last position, if my head, if my tail is equal to size. So I want to return, if tail is equal to size. And so if that's true, then I need to resize. If it's false, then I don't need to resize. So the question is then, of course, how do we resize? So template class T, and this is going to be our void Q template T resize. So if I'm going to resize, then the first thing I want to do is I want to create a new array. Let's call it temp. And this is going to be a new array, and I want it to be 2 times the size of our existing array. In general, that's a good idea to do. Just go ahead and double the space if the space that we had wasn't sufficient. And then I'm going to need to copy the data over. So int I gets 0, I is less than tail minus head, because tail minus head is really how many objects I have in my queue. And what I'm going to do is I'm going to say that temp sub I is going to get. Now I can't just say data sub I, because if I look back at my queued structure, data sub I is going to start at position 0, but these elements may have been dequeued. I actually want to start at head. So 0 would start at head, and position 1 would get head plus 1. 2 would get head plus 2. And in general, temp sub I is going to get data sub I plus head. And that's going to make sure that the data gets shifted over. And then once I've done that, then I can set my array to be that temporary array. I can set my tail to be equal to whatever tail minus head is, because if I've done this re-indexing where this is now position 0, this is now position 1, this is now position 2, and so forth, then this last position is going to be tail minus the offset of head. It's always going to be a head difference that everything's being moved over. So this is going to need tail gets tail minus head, and then head is going to be equal to 0. And then of course I've changed the size of my array, so size is going to be multiplied by 2, and that is our resize function. So we've resized our queue if we needed to resize it. So now we're ready to talk about data manipulation. So template class T, and we're going to have our void queue in queue. And I'm going to be in queuing some object. So first thing I need to do is say if I need to resize, then resize. And then I want to say data sub tail plus plus gets object. Now notice I'm taking care of a couple of things here. Number one, I'm putting object in the correct spot because this does not get evaluated until this assignment operator gets evaluated. So object is going to go in the correct spot. And then after it's been assigned, then tail is going to be incremented. Now I could write this to be clear like this, but it doesn't matter which way I do it as long as I'm doing the plus plus. So that's going to enqueue my object. Now I need to find a way to be able to dequeue my object. So template class T, and we're going to return a T. So the first thing I need to do is I need to figure out if that data has been in there. So we're going to if head is equal to tail, that's if our queue is empty. If our queue is empty, then I need to throw a std : out of range and the message attempt to dequeue from empty queue. Now remember, if I want to be able to throw these, I need to make sure that I include the appropriate file here. So we need to include std accept. So that's going to allow me to throw this exception if I ran into an issue. And then once I've done that, then I just want to return what's in data, but head also needs to be incremented. Keep in mind that when I get this data out, this data should no longer be accessible, so we increment head to the next spot. So as we did before, we can say head plus plus. And so that's going to allow us to dequeue an object. Now, peek is going to be very similar to this. So template class T, T, Q, bracket T, peek. And again, as before, if head is equal to tail, then we want to throw std : out of range. And here we're trying to attempt to peek from an empty queue. And then here, if we get to this part, we're fine, so we're going to return data sub head. And because this is the non-destructive, I don't want to get rid of that piece of data. It still needs to stay in my array, so I'm not incrementing head. All right, finally, the last thing I need to do is template class T, and we're going to have our bool q sub t is empty. And of course, if I'm empty, then we're returning head equals tail. All right, so that is our ArrayQueue. We've got our ArrayQueue.h, we've got ArrayQueue.cpp. So now what we need to do is come up with a file to test it all. So the idea for testing this, let's go ahead and call this QTest. And we're going to include IOStream. We're going to using namespace standard. And then we're going to include ArrayQueue.h. So our int main is going to look like this. First thing we're going to do is we're going to create a queue of type int, and I'm going to call it queue. And then I'm going to fill this queue up with data. So for int I gets 0, I is less than 10, I plus plus, and we're just going to say q.enqueue, and we're going to enqueue I times I plus 1. So this is just going to put stuff into the queue. It's going to put 0 times 1, 1 times 2, all the way up to 9 times 10. So 90 will be the largest number in our queue. And then I'm going to set up a while loop. So while not q dot is empty. So as long as we're not empty, we're going to do two things. We're going to see out q.dequeue and a space. And then I'm also going to do this. I'm going to put q.enqueue, and I'm going to enqueue the result of q.dequeue. So the idea is that this is actually going to do a little bit of shuffling. So if I imagine that I have something like, let me do a new page here. If I imagine I have my queue the way I've got it set up, so I'm going to have 0, 0 times 1, 1 times 2, 2 times 3, 3 times 4, 4 times 5, and so forth. Let's just say I'm stopping here. I'm going to dequeue the 0. 0 gets printed to the screen. I'm going to enqueue the 2. So the 2 is going to end up here. I'm going to dequeue a 6, and I'm going to enqueue the 12. I'm going to dequeue the 20, and I'm going to enqueue the 2. Then I'm going to dequeue the 12. Then I'm going to pop this 2 off. This is the need to resize. And I'm going to enqueue the 2. Then I'm going to dequeue the 2. So notice that my output ends up being scrambled. It's not in the same order that we were expecting. So let's go ahead and take a look at what we've got here. I know I forgot one thing real quick, and that's in my ArrayQueue.cpp, because I'm using stdxstepped, I need to make sure that I'm using namespace standard just to make sure that works. It'd be nice if this all worked. So let's go ahead and create a new terminal. I'll go ahead and pop this down at the bottom of my screen so we can see code. So we are going to compile QTest. I'm going to call it qtest.exe. And it all compiled great. First time. Awesome. So we're going to run qtest. Okay, so it gave us an issue when we were trying to attempt to dequeue from an empty queue. So let's talk about what's happening here. So we've got a 0, a 6, so notice the 2 got pushed, 12 is pushed, then to 20, 5 times 6 is 30, so it got pushed, then a 42, then 7 times 8 is 56, it got pushed, then that's 8 times 9, the 9 times 10 got pushed, that was the last number, so we're back to 2, the 12 moved, so we have the 30, the 56 got moved, we have the 90. So in other words, the issue was this last thing down here. I couldn't dequeue anything and put it into enqueue, so I really should have put an if statement here. So if q dot is empty with a not in front of it, then we can take care of this dequeue statement. And then again, if not q dot is empty without 37,000 parentheses, then we're going to do this. Now, I don't need to do it for this first one because I won't enter the loop if it's empty. But I do need to check here because this dequeue statement may pop me out. So let's go ahead and save that. We will recompile and we'll rerun, and now we made it out. Of course, I probably should have just added a cout end line just to make things pretty. And so now my prompt ends up on the next line. So what we did in today's video is we talked about the idea of a queue, a new data structure that has this first in, first out property. We talked about how to implement it using an array, and we've written a test suite. What we're going to do in the next couple of videos is we're going to talk about some applications of queues, some ways that we use them. So once again, this is Mr. Potter. Thank you for watching. Have a great day.